Good morning, Rick. Thanks for joining today. We are happy to invite you to part of our Cloud and Cloud tech community. So we are helping professionals as part of the cancer fundraising past 11 years. Now we are inviting all niche leaders to speak their experience and their use cases. Uh, so, can you just give a brief intro to our community members, Frick?
Yeah, sure. And let me go ahead and also share my screen with some more information. So, yeah, again, thank you for having me. Happy to share some of my knowledge about this topic, which is infrastructure as code. And so, my name is Freek Bersson. I'm from Netherlands. I primarily focus on application and desktop delivery technologies. So, like for example, Azure Virtual Desktop, but also a lot of experience with previous technologies like remote desktop services, terminal services, all kinds of technologies to provide applications and desktops to an end user. But I also focus on automation and more specifically on infrastructure as code for the Azure cloud. So I have been working with ARM templates for many years and took the deep dive into BiCep when it was still into the alpha release, the older one release, but actually never went back. So hoping to provide you with some inspiration on how to use BiCep for infrastructure as code technologies. So I guess we can go ahead and get started, right?
Yes, 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 Frick.
Cool. So the first thing is actually, and you might know or might not have seen this, I actually also recently published a book on BiCep, which is called Getting Started with BiCep, which allows you to, well, basically jump on technology and start using BiCep as your infrastructure as code solution. And as part of this event, we're going to give a copy away as well. So if you're interested, do send a tweet or LinkedIn message and make sure you mention me or the Cloud and Loud event, and we'll draw a winner at the end of the event to give one a free copy, paperback version of the book. So happy to do that. So before we dive into the BiCep content, it's good to take a look at where to sort of position BiCep as the overall infrastructure as code technology for our Azure platform. So this is a diagram of the Azure Resource Manager. And the Azure Resource Manager is basically our front door to all of the resources and all of the resource providers that we have in Azure. So whatever we're going to create or update or delete, we always need to pass that ARM engine. And that is because regardless of the technology we use to talk to that ARM engine, whether that's the portal or Azure CLI or PowerShell, we always have to pass that ARM engine, which makes sure that all of the creations and all of the updates and all of the requests that we send towards the Azure cloud are always treated in the same way, with the same API version, with the same rules, based on the same resource providers. And so for this case, we're talking about ARM templates first. So you might be aware of ARM templates, which allows us to create resources in a declarative way. So without going into the Azure portal, using the UI, or without using a sequential language, for example, Azure CLI or Azure PowerShell, where you initially have to provide a sequence of commands in order to create or update or delete a resource, we're going to create an ARM template, which allows us to do that in a declarative way. So an ARM template essentially has a super simple structure. It is structured with 4 main areas. So besides the content version and the API profile version, as you can see here, it's basically all about providing parameters, which allows us to change the deployments to our needs and have our templates also be reusable. We have the concept of variables, which allows us to create some static values that we're going to reuse across our template. But for the most part, it will all be about the resources section. So this is where you define the resources you're going to create in the Azure portal, whether that's a virtual machine or a network adapter or a SQL server or a Kubernetes cluster. Those are all resources inside that resources section. And the last one is outputs, and this allows you to also have an output as part of the deployment of your ARM template. So when you take a look at this template format, it's pretty easy, right? It seems pretty simple. But that all changes when you actually start to use ARM templates. You run into templates like this. So as you can see, there is a lot of syntax overhead, a lot of complexity in these ARM templates as well. So although ARM templates are very powerful in terms of infrastructure as code deployments and making sure you don't have configuration drift in your deployments, these templates are not really easy to read and easy to digest and author and to debug. And the whole reason is that these ARM templates were initially intended for computers to exchange information about the deployment. So they were not initially meant to be able to read and to author and to use in such an infrastructure as code language. So Microsoft also realized that a couple of years ago, and this is a tweet from Mark 𝐕𝐢𝐼𝐶, which is the Azure CTO currently, and he stated in September 2020 that Microsoft is working on a new concept called BiCep, codenamed BiCep back then, which would allow us to have more simplified declarative way of deploying. So providing the same power as the ARM templates, but then in a much read and easy to author way, and remove all of the syntax, overhead in our ARM templates, basically. So what is then BiCep? BiCep, in short, is a DSL, which stands for Domain-Specific Language, which means it was specifically designed for the Azure cloud. So you cannot use that outside of Azure, like, for example, what you do with Terraform or other languages that do allow you to do that across different clouds. BiCep is really intended for only the Azure cloud. So essentially, it does the same thing as ARM templates. It allows you to provide and create and update your resources in a declarative way by stating them into a BiCep file, but then without all of the overhead of an ARM template and all of the complex syntax and the syntax overhead. So it really drastically simplifies your authoring experience, and we'll show a couple of live demos of what it actually looks like. That's a much cleaner and easier to read and to author language, and also provides with a lot of options to do modularity, to be able to reuse your code, for example, to deploy towards a test environment and a production environment, or to deploy for customer A or customer B. And BiCep is really the transparent abstraction layer on top of ARM templates. So we often get the question whether BiCep is going to replace ARM templates or ARM technology, and it's not. It's going to be an abstraction layer on top of ARM templates, so still using ARM and ARM technology, but then sort of masking all of the syntax overhead that you get with an ARM template. And we'll see some experiences of that in the live demo in just a second as well. So before we go into the demo, where should we then position BiCep as the language? So right-hand side is sort of simplified architecture of the ARM engine again. So with the big blue bar, the Azure Resource Manager engine, that is still going to be our front door to the creation and working with all of the resources that we have in Azure. And on top of that, we still have ARM templates. So we are still feeding ARM templates into that ARM engine. But on top of that, we have the BiCep language. So this allows us to not have to author and to read and to debug our ARM templates, but instead we use the BiCep language. So basically what you do is you create a BiCep file, and I'll show you that in a demo in just a second. You transpile it into an ARM template, and then you feed that ARM template into the ARM engine. And then in the meantime, you can also directly provide these BiCep files directly to the ARM engine as well. So this removes the need of having to view and debug and work with ARM templates and still have all of the power of the ARM language, the ARM engine, and the infrastructure as code approach. So this entire project is also open source, which means that if you go to the GitHub location where Microsoft provides these sources, you can take a look at the source code of BiCep. You can provide pull requests to, for example, suggest any changes or any new features as well. The entire process is transparent, is open source, and also allows the community to add and suggest any changes that they would like to see inside the BiCep language. So to get started with BiCep, a couple of things that you need. So first of all, you need the BiCep CLI, the command line interface, to be able to work with ARM, with BiCep templates and transform them into ARM and to deploy them to the portal, etc. You need VS Code. At least that's the suggestion that I would do, because there's a lot of extension capabilities inside VS Code specifically for BiCep as well. And you either need PowerShell or Azure CLI to be able to deploy these templates to the Azure portal. So whether you use PowerShell or Azure CLI or some kind of DevOps or automation, that is all possible. But I advise you to use VS Code as the coding application. So that's all you need. And let's actually go into a demo to see some of this in action as well. So let me open up VS Code. So we could take a look at the version of BiCep that is currently installed on my local machine, which is 0.4.13.10. The other thing that I did is install the extension. So if I go to the marketplace here, search for extensions, I search for BiCep, we can see that the BiCep extension is already installed with a version in there as well. So this is the extension that allows us to do things like validation and IntelliSense and dot property access and all kinds of features we'll take a look at in just a second as well. So let's go ahead and actually start creating a first new BiCep file to sort of give you an idea of the power of BiCep language. So let's start to declare a new resource we want to create, for example, in the Azure portal. We start with the keyword resource, followed by what's called a symbolic name. We'll touch on what that means in a second. But now I'm able to provide the storage account in this case. So the type of resource I'm going to create in the Azure portal. And as you can see, I get a nice drop-down list, which allows me to easily select the storage account, select the API version, and the next thing I do is an equal sign and a couple of brackets. What I've now declared is I'm going to create a new resource with a symbolic name SA, with the type storage account, and with an API version date in there as well. Next thing I need to do is I need to provide a couple of parameters, of course, in order to make this declaration complete. So the first thing I need to do is provide a name for this. Let's just call it as a demo 2022. And I also need a storage account kind in this case. Let's for now choose a blob storage. I need a location, of course, where to store this, in which Azure data center. Let's do West Europe. That's the location that I'm in. And we need to provide a SKU, and SKU is actually multiple properties. So we need a bracket here. We're going to provide a name, and let's do standard LRS. And that's it. So as you can see, IntelliSense helps me along with providing the correct values with all kinds of nice drop-down lists. So really helping me along while I'm authoring this template. So what is also great about BiCep is that I can point to existing resources I have created as well. So for example, if I would have to create an output for this template, I would use the keyword output. I would give another symbolic name. And I would say that it's equal to a string and equal to SA. And SA now points to the resource I have declared here before, right? So that's the storage account. So I can, for example, browse to a couple of properties that storage account has. For example, properties. Let's take primary endpoints and let's do blob. So as you can see, again, IntelliSense helped me with the dot property access in order to get the correct property of this storage account in this case. So let's make this template actually a little bit more reusable and start introducing a couple of parameters. So I would use the keyword param here. And for example, let's do storage count name. And it's going to be a string. And let's also give it a default value, which is actually the value that we provided here. So let me go ahead and copy that in. Now we have a parameter we can use across our template. So I can replace this static value for a parameter name. And similar, what I could do is create a location parameter, also going to be a string, and it's going to be equal to West Europe. And now I can replace this hard-coded value with a parameter as well. So now I sort of have a small first BiCep template, which allows me to create a storage account in Azure by providing a couple of parameters during runtime as well, with a couple of default values and an output of the blob storage of that primary endpoint. So let's take a look at how complex that will be inside an ARM template. So what I could do is I could say BiCep build. So it's the build command and then providing the file name. So the two main.bicep file. Hit enter, and on the left-hand side, you can see that we get created a JSON template. So this is the JSON ARM template equivalent of our bicep file. Let's open it up side by side and actually see the difference. So you can already see that we went from 13 lines of code towards a good 39. So as you can see, there's a lot of complexity on the right-hand side with all of the brackets and the commas and the semicolons going on, where left-hand side is super easy and clean to author and clean to read as well. So that's a first example of how to create a first resource in Azure. So I could take this bicep file, provide it through the ARM engine, and have this storage account be created. The next thing I want to show you is actually a much more faster way to also create this resource. So as you just saw, we already had a couple of IntelliSense things with the properties and the dot property access as well. But what I could also do is actually remove this here and use something that's called scaffolding. So again, let's do resource, let's do SA, let's do a storage account. And instead, let me actually do that again because I wanted to show you what that looks like. Second. Storage account API version. If I can now do an equal sign, I also have an option that's called required properties. So if I do that, I instantly get all of the required properties for this resource. I can just fill this in, use tab, go to the next location, provide a location, have these drop-down boxes here, and have that be created. So without me knowing about all the properties of this resource, I can just scaffold out all the required properties and work from there. And what's even cooler to do is I can also provide something that's called a code snippet. So instead of using the resource keyword here, if I would do a res dash sign, I can get all of the code snippets that have already been prepared by others. So for example, if I wanted to create, let's create a host pool, for example, for Azure Virtual Desktop, I do res wvd host pool. I hit enter here, and I can initially get all of the properties with all of the default values that are in there based on this code snippet. So code snippets are provided by Microsoft, by the community, for example, in order to allow you to create these resources in a super fast and easy way. So just another example of how easy it is to create these resources as you go. Another great thing about these parameters here is I can provide a couple of parameter decorators. So for example, if I would create a, let's say a new parameter here, let's say that first, for one reason or another, I need a password. And I'm going to provide a string, but it's going to be a secure string. Oh, not secure object, a secure string. And it's going to be equal to not so secure password. A couple of things are happening here. So as you can see, I have a secure decorator here, which makes sure that this password that I pass here doesn't end up in log files or in deployment history in Azure, etc. But I also get these two squigglies here. So I have a yellow one indicating that the password parameter is not used within this template, which of course makes sense because we didn't do that yet. But I also have one in red here indicating that secure parameters should not have hard-coded values. That's of course true because I should not hard-code any passwords inside my template. So the reason that I get this error message here is because I have a file here which is called bicepconfig.json, which has a couple of rules in here. And one of those rules is that secure parameters by default should error out if they have a default value. So this is actually a couple of rules that allows me to make sure that I comply to my own rule set, to my own coding standard, to my own agreement within the company or within the deployment that I'm working on. So if, for example, I don't want that error message here, but instead I want a warning, I could change that into warning, hit save here. You can see that now I have a yellow squiggly instead of a red one, and I still would be able to deploy this template. So just an example of how these things work, and they're called linter rules, which allow you to make sure that the code is actually compliant to your own coding standards. So that is a couple of things in order to, create your first template. The next thing I want to show you is a more advanced template. So let's open up a new file, which is called VM Bicep Demo. So as the name already suggests, we're going to now create and declare a virtual machine in Azure. And you probably know that the virtual machine consists of multiple resources in Azure, right? So we have, in this case, a virtual network we're going to create. I have a network adapter we're going to create, and I have an actual virtual machine object. So let's, as a first step, actually transpile this into an ARM template. So again, we could use that bicep build command, but the other cool way is I could also write this file here and simply say build. So now I get the JSON equivalent again. We can open up side by side. And again, we can really see the difference in, well, the easy to read left-hand side versus all of the complex syntax overhead on the right-hand side. The thing I wanted to show you.
So the JSON and the bicep. So through this, we are making more easier than JSON. Correct.
Yeah, much more easier. Yeah, so the left-hand side does exactly the same thing as the right-hand side, but left, as you can see, and I mentioned that is much more easy to read and to author and to, well, to write and to write as an ARM template or bicep templates creator. Yeah.
Okay. Okay.
Yep. But the thing I also want to show you is that if I, for example, would go to one of the resources here, which is the network interface, we can see that there's a section here called depends on. So this is us telling the ARM engine that before we actually create this type, so this network interface, the virtual network needs to exist, right? So that's a dependency there. But if you take a look at what it looks like in Bicep, scrolling down, there's no dependency section here. So the question is, how did that depends on section get into that ARM template? And the reason is that we're using and leveraging properties of a previously declared object. So I have here the creation of a virtual network. And as part of that, I need to point it to a subnet. And that subnet I'm going to grab by declaring the VNet and then getting the ID of the VNet. So because I'm getting properties of a previously declared object, Bicep actually knows to add this depends on section for us. So we don't have to worry about dependencies anymore. Those are all being added automatically as part of the Bicep, CLI. So that's another great thing about the Bicep language. And we also mentioned in the slide deck the concept of modules. So let's also take a look at that. So I have another example here. In this case, I have a set of parameters, and I also created an array here of different properties. And I have a resource declaration. That's all things we've seen before. But also notice that I have an if statement here. So this allows me to also provide conditions. So let's say that, for example, I only want to create this resource group into when a certain condition is true. I can use this Boolean if deploy resource group. And deploy resource group, again, as you can see, is a parameter here, which states true. But if I would deploy this template and state false, this resource group would not be created. So this allows me to have conditional deployments in Bicep as well. But the thing I wanted to show you is modules. So in this case, we're not using the resource keyword, but we're using the module keyword, which allows us to leverage an existing Bicep module. So we provide it with a symbolic name and then pointing to the name of that Bicep file. So this allows us to use all of the code declaration inside this module, not have to rewrite and reauthor it again, but simply inject it into our Bicep file. So we provide it with a scope, which means that we are able to also provide the resource group in which it's going to be deployed. We provide it with a couple of parameters, and we're now leveraging this module. So for example, in this case, it's a VNet model, so it's creating a virtual network for us. But if I were to do this for a customer A or customer B, I could just use that same module, provide different parameters, and basically start reusing my code for different customers or for production and test environments or for different departments, etc. So that's all about being able to reuse that code. Another great thing about using modules is we can also use it in combination with loops. So loops allows us to create multiple instances of the same resource or the same multiple resources, but only declaring them once. So as you can see, I have the declaration of a module here again, but I actually added here a for loop. And this states that for each AVD backplane inside AVD backplanes, which is an array, I need to loop through this bicep file. So this allows me to create multiple resources, in this case of the Azure Virtual Desktop module, without having to declare them multiple times. So I could just loop through a certain array or a certain value in order to create multiple virtual machines or multiple network adapters, or in this case, multiple Azure Virtual Desktop environments. So the more you start to work with bicep files and the complexity and adding more codes and adding more resources, you sometimes want to have a sort of graphical representation of what you're actually going to create. And the great thing about Bicep and VS Code is that it actually allows you to do that. So if you right-click here and say Open Visualizer, this provides us with a visualization of what we're going to create in Azure. And as you can see, it has a nice diagram with the modules, with the resources and the resource names and the types, etc., allowing me to get a good representation of what we're going to create. So I can use this as documentation or providing it to someone else to get more insights on what they're going to create.
So this looks cool. So when we create bicep, automatically we can also represent as a workflow diagram.
Yep. And this
Okay.
diagram is also interactive. So I can change this to whatever I want to have it, or change
Okay.
it or add values as well.
Okay.
Or actually revert to what it looked like in the past. So yeah, like you said, definitely really helpful as you start to create resources and want to get an idea of what it looks like. The visualizer definitely is your friend.
Okay.
What is also great about the visualizer is that it's also interactive in a way that, for example, if I would open up the visualizer side by side, which you can also do, it is also automatically updating. So for example, if I would create another resource here by simply copying and pasting this resource, adding it in here and providing a quick unique name, we can see that on the right-hand side, it's initially added, right? So as long as you are adding all of the code and all of the resources, you can have another screen or another, in this case, side by side, which helps you along the way and get index be visible as well. So really, really helpful in that area. That's the Bicep visualizer. And well, of course, these are just a couple of objects, but let me actually show you a bigger example, which contains a lot of resources, which is my 6 main.l. If I would open up the visualizer here, we can now really see the power of the visualizer, because now we have a lot of resources. I even need to zoom in to actually be able to read it, but a lot of resources that are being created with all of the dependencies and the relationships between those resources, which allows us to get a really good sense of what we're going to create. So the more templates you start to use, the more modules you start to use, the more benefit you'll actually get for this visualizer as well. So the last thing I want to show you before we go back to the slide deck and provide a quick summary is the process of decompiling. So you might actually have ARM templates already be created as part of previous projects, or you might have downloaded some JSON templates as well. And the question we always get a lot is, am I able to transition a JSON file back to Bicep and start reusing Bicep from that moment on? And the answer is yes. So if I would do a Bicep decompile, and I would provide, so for example, file number 8 here, which is a WVD to decompile JSON file, hit enter here. And as you can see on the left-hand side, we actually get the Bicep equivalent be created. So I can open it up side by side again. And actually, oh, this is not the correct. Let me do that again. So I have number 8 here. Open it up and side by side. So left-hand side is the one that actually was created based on the ARM template. So we started with an original ARM template, and whether this was downloaded from the Azure portal or downloaded from some kind of GitHub location, or maybe you authored your own ARM template in the past, the decompile allows me to decompile back to Bicep and then start using Bicep as the new file. Now, of course, the decompilation is at best effort, as is stated in the warning here as well, because not all features that are inside BiCep are also in ARM templates, but it really allows you to get a jump start on existing ARM templates and making the transition to start using BiCep as well. And the other thing is that, for example, if you don't have an existing JSON file, but rather you have, for example, an existing Azure object, and let me actually remove now, and show you the Azure portal. So we go into the Azure portal, and let's just select a random resource here. So let's go to virtual machines and pick one of the virtual machines inside this list. And we go to JSON view. This already provides us with the JSON view of this resource. I can actually copy the link, the resource ID, to this resource, go into an empty BiCep file, go into command palette, and select the option BiCep insert resource. Paste that value, hit enter, and now the Azure, the BiCep CLI engine will actually grab the resource, get the JSON file, and initially already transpile it into BiCep again. So this is the BiCep command, the BiCep template for creating the virtual machine that I just had in the Azure portal. So this really allows you to get a jump start and sort of do an analysis on how a certain resource is being created, to do some reverse engineering, to get an idea of how a resource is created in the Azure portal. Just grab any resource ID from any portal, from any location in Azure, copy it in to actually see what the BiCep would look like. So this is a great starting point if you're new to BiCep language and want to get an idea about the syntax, to get some idea of what a BiCep file looks like. Any questions? So far?
No, Frick. This is going to be really helpful for many people.
Yeah,
Exactly.
for sure. Yeah. Okay.
As I can see, it's very easy to understand as well, Preet.
Yes.
Yeah, it is, and especially if you compare it to the JSON language, it's like I said, the JSON language is really intended for machines to exchange data about certain resources, and the BiCep language just really focusing on the authoring experience with all of the extensions in VS Code as well. So yeah, it's definitely a great help. It's one of the reasons that I never went back to ARM templates about 2 years ago, because of the simplicity and all of the code extensions that you get as part of BiCep. Okay, so hopefully that was an interactive and fun demo to see. So let me go back to the slide deck and to provide a quick summary of what we have seen today. So this is the roadmap of BiCep and where BiCep actually came from. So it was initially released late 2020 in August with a alpha release. Really the first release, a couple of objects that were only available, but the first time BiCep actually was publicly available as part of the GitHub location. And as you can see, it transitioned into what it is today. So right now we are somewhere between the O and the 0.5 version. So a lot of the 0.4 versions, a lot of the functionality is already in there, like the linter rules and the snippets and the resource scaffolding we saw in the demo, and a couple of other things were going to be added soon as well. So we are still expecting to be the 0.1, the 1.0 version somewhere this month, or probably April by now. But a really cool thing that is going to be added is the ability to actually pass an entire resource towards a module. So we took a quick look at using modules and providing values to these modules in order to provide parameters. But it's going to be possible to also provide an entire resource to a module and actually read the properties of those resources inside the module as well. And the other thing we didn't really touch. Cool. Yeah, it's really great. Yeah, it allows you to have, not have an entire list of properties, but simply provide the entire resource to that module. So definitely looking forward to that. We didn't really touch on is something that's called registries or module registries. So the example that we had in the demo where the BiCep module was stored on a local file system, that's not really ideal in terms of code sharing with other colleagues or other developers in your department. But the private module in Azure and then use the role-based access control inside of there to share that BiCep module with other co-workers as well. So basically work on the same modules and work on the same pieces of code. So private registry is already available today. So it allows you to have a private repository in Azure based on an ACR. And public registry is going to be added as part of the 0.5 version, probably somewhere this or next month. We're expecting that.
Okay.
So another common question before we wrap it up is always, well, we're looking at an 0.4, 0.5 release. Is BiCep already ready for production usage? And the answer is definitely yes. So since the 0.4 release last year, BiCep has been ready for production usage as well. So there's full support for Microsoft support. There's all of the docs pages and all of the documentation, etc. The only reason it's not a 1.0 version yet is that they're still waiting to make it an official release in terms of policy changes, stricter policy change, to avoid any breaking changes that we do inside the code. But other than that, I personally have been using BiCep for production since 0.3, 0.3 version already. But it is definitely ready for production usage since the 0.4 release.
Okay. Okay.
So what do you recommend for the people who don't have any previous programming language, I mean programming skills, and new to the Azure and new to the BiCep freak?
Yeah, that's a great question. I think that for a big part, the BiCep language is all about being a declarative language. So you don't necessarily have to have programming knowledge in terms of sequential programming, like, for example, PowerShell or Azure CLI does with all of the commands that need to be processed. But it is, of course, handy if you have, well, some ARM experience. It's definitely not needed, but if you do have ARM, easier to transition to BiCep as well. But I think my best advice would be to first understand the concept of infrastructure as code, so what it actually means. And then take a look at, for example, some simple examples to get a first resource, or like we've seen with the decompiling, so to decompiling existing resource into BiCep and actually seeing what's going on. And definitely also use the VS Code with the coding extension in there along the way as you are creating your first.
Okay. Okay. I think this will be really good for many people who really using Azure Cloud extension
Yep.
for all their infrastructure automation or hosting
Yep.
or their data related projects.
Yeah, and I think that many developers, many organizations were sort of scared when they actually saw the first JSON templates because they're so complex to read and to digest.
Yes.
This
Yes.
actually allows you to have a much steeper learning curve in actually starting to use infrastructure as code and get all of the benefits of, like you said, automation and well, maybe Azure pipelines, etc. So definitely helpful for those organizations that want to take the next step into public cloud and using infrastructure as code. Yep.
Yeah. Thanks, Rick, for your time.
Yeah, thank you,
Probably
Freak. It was a great session.
Yeah, you're welcome. And yeah, thank you for having me. And well, again, if there's anyone who wants to win a copy of the book, I actually have it right here. So make sure to send a tweet or a LinkedIn message, and I'm happy to draw a winner at the end of the event. But yeah, thank you for having me, and hopefully it was valuable content.
Thanks, Rick.
Thank you, Freak.